My name is Cesar Saavedra, and I'm a developer advocate with GitLab. This is a vendor-neutral presentation, by the way. I've made it as vendor-neutral as possible, except for the demo at the end. I'll show you GitLab. So what I plan to cover today is these three main topics. First of all, talk about the current challenges in DevSecOps. A bit of an overview of the different approaches or phases in the evolution of DevSecOps. And lastly, we're going to show you how to do an optimal workflow in DevSecOps, and then talk about how you can leverage AI to make you even more productive and more efficient while you're deploying, planning, deploying, building, deploying, and monitoring an application. And we're going to close with a recorded demo. I didn't want to go live because I don't trust conference Wi-Fi. So, all right. And then I will try to have some time at the end for Q&A. Okay. So let's talk about the challenges in DevSecOps. So this is a typical environment of an organization. We see this all the time. An organization that is doing DevOps or DevSecOps, and they have a collection of different tools to do different tasks in the software development lifecycle. I put some names in there. Jenkins is a typical pipeline software. CI/CD software. GitHub is a typical product for version control. There's Argo CD. There is Sneak for testing, Datadog for monitoring, JFrog, etc. So this is a very typical setup in an organization. And the problem with this setup is that all these different tools have different UIs. They're completely disparate, separate. They don't share any data. And you have to basically, as a developer or a stakeholder, you have to context switch all the time from tool to tool, which hinders, productivity, collaboration, and all that. Now, these are some numbers from our last DevSecOps report from last year. And this is just kind of confirms or validates what I just showed you in the previous slide. So 69% of developers spend at least a quarter of their time maintaining and integrating tool chains. Okay? So instead of, as a developer, what you want to do is you want to spend your time innovating and writing new code or maintaining code, but you don't want to spend time actually working on integrating the tools that you're using. Another important number here is 66% of organizations would like to consolidate their tool chains. One of the things that we often see is that organizations that have multiple tools, they have to spend subscription money, right, on each of the different tools. And right now, with budgets getting smaller, there's a concerted or a general desire to reduce the number of tools in an organization. Also, and lastly, 84% of organizations are using between 2 to 10 tools. Okay, as I mentioned, typical situation is Jira, GitHub, Circle CI, I'm sure you've heard of that, or Jenkins, and Datadog, etc. Very good. So let's switch topics now to what the different approaches are within an organization. Now, the bring your own DevSecOps is what I mentioned before. This is just a collection of different tools. This is the problem that I described earlier. The tools have different UIs, different data sources, and usually in this type of organizations, each team or each project within the organization is free to choose whatever tools they want. So you also have a lot of duplication, okay, which means more cost or higher cost. Now, the next approach is the best-in-class DevSecOps. So this is instead of letting everyone use whatever they want, let's try to consolidate have a standard set of tools that everyone uses, right? And usually in that case, the tool for doing CI/CD is one single tool for everyone, right? And it's what they deem is the best in class. So you pick the best in class of each, and then you say, everyone from now on, this is the standard, everyone is going to use these tools if you're doing software development or any kind of development. Now, so the tool chain here is standardized. Now the next approach, or the next step in the evolution, is the DIY, so do it yourself. So think of this as having this standard set of tools, but now you have built integration points between them. Now you are spending time, because you've authored these integrations, you have to spend time maintaining them, right? Now usually if you're an insurance company or a lab, for example, you're not a software company, right? So you want to spend time, again, you want your developers to spend time creating new applications or new offerings for your customers, not spending time working and maintaining integration between or among these different tools that you use in the development lifecycle. So that's DIY. So lastly, it's the DevSecOps platform. The idea here is that you have a single application that covers all the phases of the development lifecycle and has a single UI and a single data store. So now this doesn't mean that you have to use every single capability in this tool, right? If you love your Jira, you can use your Jira and also a platform for the rest of the stuff, okay? So, but a platform, the benefits or the advantage of having a platform is that since this platform has a single data store and a single data model, the platform is able to capture metrics along the way across the entire development lifecycle. And this way you can get visibility, not just into the application, but also into the processes, the development processes. So you can measure things like, how often are we deploying code? What's the deployment frequency? What is the mean time to restore a service? How long does it take us to restore a service? How often, how frequently are we failing in production? Things like that. And usually these dashboards or insight is already built into the platform, and you get that with the platform. You don't have to. In the case of DIY, you're working on those integrations yourself. You're having to extract the data from each of the tools, normalize the data, and then generate the metrics, calculate the metrics, and then create a dashboard to get any insight into the whole process, okay? So you get that all for free or included in the platform approach. Now, usually the goals of customers and end users is the same, right? Within organizations, they want their developers to be productive or more productive. They want to simplify the toolchain complexity, like we mentioned before. And also they want the software that they create to be secure by default. And now with the advent of AI, they want to be able to leverage AI in their processes. And this is what this presentation is going to be about also. We're going to talk about a prescribed and opinionated workflow on how to do DevSecOps. And then we're going to talk about how AI can help you do that even better than before, or more efficiently. All right, so going back to the DevSecOps platform, I already kind of mentioned this, but this is what a solution that is a platform would look like, right? You have all the phases of the development process there, whether it's, plan, create, integrate, all the way to monitor and improve. You have a single data store that allows you to get this insight out of the, end-to-end insight for all the processes that you're exercising within the platform. And it supports CI and CD. Plus, you have AI capabilities that help you be even more productive and efficient. All right, so let's talk about what a typical workflow or, a prescribed workflow would look like when it comes to this platform solution. So this is basically a typical workflow where this is not just for developers. It could be for stakeholders that participate in the development of the application. It could be for SREs, can be participants here, operators, administrators, developers, testers. They can participate in this workflow. You start with the planning, with epics, milestones, issues. You assign issues. In here, you can create also iterations. If you're using sprints, you can have that here too. Then you start assigning the work through the issues. Now you create merge requests. Now a merge request, many of you probably know it as a pull request. Know that as a pull request. We call it, instead of PR, we call it MR. So you create the merge requests, and then you start, either changing the code, improving it, or creating new code, and you're pushing code. It's typically into a branch, right? Not the main branch. Obviously, definitely not production. And then you automate the test, and you want to do this here because if you heard of that concept, shifting security left, that's what that means, because we're pushing the testing, the security testing, all the way to the left of the pipeline. That's why it's called shifting security left. This is the automated test right there. And this happens automatically, right? Whether it's static testing or dynamic testing, whether it's license management tests, whether it's license scanning. There's tons of scanners available to you that you can use to verify and make sure your code is secure. And that's a scan bubble right there in the middle. Now, during this inner loop or inner feedback loop in the center here, this is also where the reviews take place. Okay, there's collaboration. You ask people to review your code or your changes. People will leave comments, will suggest new updates, and at the end of that, there will be an approval process. Okay, once everybody approves the changes, then you can go ahead and merge the changes to the main branch. Now you can do, before you merge, you can do from the push code all the way to the approval. You can do that over and over until you're satisfied. So that's what we call the inner feedback loop, and this is typically where the application gets improved. Okay, then you merge the code to the main branch, and we're now at the end over there, and then it's time to release. Right, there are many ways you can release that code to production or to staging or whatever environment you decide to release that code to. And here you can think of things like blue-green deployment, canary deployment, incremental deployment, things like that. Also feature flags. I'm not sure if you're familiar with that, but a feature flag is basically, it allows you to determine how small or large your audience is going to be that will see this new feature. You can decide to give access to a specific user if you want. You can give access to a percentage of your audience. You can give access to a group of people. And these are all different ways to, feature flags, in a way, it allows you to test in production. Okay? And once you're comfortable with a feature that is in production, let's say you've deployed it to a specific group, then you can open it up to everybody else. So that's feature flags. That's just another way to deploy software. And that completes this opinionated prescribed workflow. Now, I mentioned an inner loop, feedback loop in the middle that allows you to improve the application. Now, there's also a big loop, because once you've deployed, you can monitor the application. And not just the application, but once you've deployed, at the end of this process, you can also get insights into the whole process. How long did it take you to deploy this application or to finish this application? So, and how well did we execute those processes? So that's the outer feedback loop that allows you to improve the application and also improve the DevSecOps processes. Okay. All right. Okay. So now the question is, this prescribed opinionated workflow makes you productive and efficient. So how can you leverage AI to be even more productive and more efficient? All right, so there are many ways to leverage AI in this workflow. Now, the idea here is that I'm sure all of you have heard of code generation and code completion, right? This is when you're typing your code in the editor. As you type, a piece of code is suggested to you, and you press tab to accept it, or you continue typing. Or that's code completion. Code generation is when you use a prompt. As a comment, you put in a summary of what you want. It could be a paragraph saying, I want a function that does this, A, Y, Z, whatever. And then the AI generates that function for you. And then at that point, you have the option to accept or not. So that's code generation and code completion. So besides that, there are many ways. The idea is that to leverage AI along the entire workflow that you saw, not just for code generation and code completion. So the question is, where else can I use AI? So we can go from left to right, top to bottom. So you can use, for example, AI to generate the issue descriptions. And the reason that this is a good place to leverage AI is because a lot of the issues are repeatable. For example, you want to provision a new node in your Kubernetes cluster. This is, the steps to do that are, pretty well established. So you can create an issue. In the issue description and the issue title, you just put something brief, but then you can use a prompt to prompt the AI capability to tell it, listen, generate a description that may contain multiple paragraphs that gives me a plan on how to add a node to my cluster. So the idea is here, you get a bunch of paragraphs and the steps on how to do that. The idea is that now you can start from that point instead of you typing the whole description of the issue. Okay? Again, that makes you more productive, and it helps you get your job done faster, basically. Summarizing an issue discussion. I'm sure you all know that as people start working on an issue or talking about an issue, multiple people can collaborate, and then the issue can be pages long, right? So let's say you go off on vacation, or you have a new member of the team that you want to onboard, and then now this person has to read an issue that is, 20 pages long, and with comments with a bunch of different people. So the idea here is you can, again, invoke or leverage AI to summarize everything in that issue into a concise paragraph. Of course, in natural language. And the whole goal here is that once you read that paragraph, you can start working right away. Okay, instead of spending an hour or however minutes you need to take to read 20 pages, right? So that's summarizing issue discussions. We already talked about code completion and code generation. Now, code explanation is very, very interesting because let's say you are assigned into a new project and you have to maintain a piece of code that someone else wrote. And I used to be a developer, and sometimes you just don't have time to write a lot of comments, right? So somebody inherits that code, and then they want to understand what the heck is happening in that chunk of code, right? So you can select that function or that chunk of code and invoke AI, and it gives you a natural language explanation of what is happening there. So again, the idea here is that by leveraging this AI capability, you can get to start work faster. Also, that works for someone that is maybe just new to the language, right? Code explanation is a good option there. Test generation. For those of you doing test-driven design, probably many of you are aware of that technique. TDD is basically, when you write new code or a new functionality, when you commit the code or you're creating the new code, you have to write the test with it, okay? So you can leverage AI in this case to generate those tests, to make sure that all the setters and all the getters work. So again, that saves you time. You don't have to write all the test unit cases. You can just have the AI generate those for you. Root cause analysis, I use this a lot, and it's super useful to me. So when you run a pipeline, many times the pipeline fails, right? And then you have to look through the logs, and then you have to spend time researching what went wrong in the pipeline, okay? And with root cause analysis, there is a troubleshoot button that you can use. And basically the AI what it does is it understands the context of your application. It goes through the log files of the pipeline, and it will give you an explanation of what went wrong. But most importantly, it'll give you suggestions on how to fix it. So it will lead you into the right direction, okay? So I've used this many times, and if it says me, instead of, spending an hour trying to figure out what's wrong, within minutes, it leads me into the right path, and I can get the problem solved quickly. All right, just like issue summarization, like I mentioned before, MRs or PRs, they can have a very long discussion thread. This summarization will do the same thing. It will generate a short paragraph of what was discussed and agreed on within that MR long thread of discussion. Merge commit message generation is great because how many of you, when you do a commit, the default message is updated file.x, and you just go like commit, right? You don't bother typing something in there, explaining what you did. So you can invoke merge commit message generation, and it'll read what you did, and it'll add a nice line or 2 lines of what happened in that change in human readable form. Again, this helps, for example, for someone that is doing reviews or trying to understand what changes were made in an application. CLI completion, how many of you have to look at when you're doing a git command, what's the next option, right? Or what option do I need to use? CLI completion helps you with that. Is really cool. I've used it a lot. I don't have to look through pages or do Google of the different options for the git command. These next two are pretty nice too: vulnerability explanation and resolution. So this is, I mentioned earlier, security scanners. So the security scanners, when they scan your code, they will spit out what they found wrong with it, any vulnerabilities. So with explanation, you can actually say, explain this vulnerability to me. And instead of you trying to do research on it and looking through this specific vulnerability, it'll just return to you what the vulnerability is about, how an attacker could take advantage of that vulnerability, but most importantly, it'll tell you how to fix it. So you can actually go back to your code and fix it yourself. But if you are, if you want to save some time and not fix it yourself, like make the changes yourself, you can take advantage of vulnerability resolution, which will start a new MR with the changes in it already for you. So that saves you some time. You can just review it and then make minor changes if needed, and then create the MR, or click on create. Code review summary. This is for code review people. Like when they are reviewing your code, somebody might have made 10 suggestions in one file, 20 suggestions in another file or comments, and then you receive all that. You're the author. You receive all those comments from everybody, and you go like, oh my God, what am I going to do? I'm going to read through everything. What you can do is you can say code review summary, and it'll review everything that was suggested to you. Again, in a small paragraph. It could be a list of things that were suggested to you for updates in your code. So that's code review summary. It's a major time saver. Lastly, chat. Chat is basically a place where you can ask any questions really about what you're doing. How to fix a problem, how to create a file, how to request for the contents of a specific file. How do you create a specific construct in a pipeline or a language, for example. We're going to see that in the demo. Okay. Lastly, before we jump into the demo, I just want to show you this. Remember the workflow that I showed you before, the opinionated workflow? The green lines are the different AI capabilities that I just mentioned, and notice how they are spread out through the whole workflow. So it's not just about code generation and code completion, it's about leveraging AI across the entire workflow so that your entire development lifecycle gets better and makes your life easier as a developer or participant in this process. And one more thing that I didn't mention is if you look on the right side at the bottom, it says AI Impact Dashboard. Many organizations, they want to know, okay, so I'm using AI. How do I know if it's good? I want to see the results. How is it helping me? So I shouldn't say we, but one of the things that a platform can provide is an impact dashboard that shows you the benefits. How is AI helping you become more efficient and more productive? This is something that a platform can offer to you as well, out of the box. All right, demo time. So what we're going to do here is we're going to use AI to create, build, and locally run a Quarkus native Java application. Does anybody know what Quarkus is? Raise your hand. Okay, good. Okay, a few. All right, so you guys know what Java is, right? It's a language, okay. So Quarkus, so Java is interpreted originally. So what Quarkus does, it compiles Java to an executable. Okay, it's like compiling a C program. So it takes Java and compiles it to machine code, and it runs faster, it starts up faster, it uses less memory. Okay, so that's what Quarkus is. So we're going to use AI to create a simple application, and then after that, we're going to use AI, and we're going to test that application on the laptop. And then after that, we're going to create a pipeline to be able to do all that, but on the cloud, to send it to a cluster. Okay. So let's go there. Here you go. So here, I recorded this, and what I wanted to do is, I want to start from scratch. I had nothing, okay? So I wanted to create a Quarkus application, a simple one, and I wanted to chat with the AI here. This happens to be a GitLab Duo chat. This is Visual Studio Code, by the way, okay? There's a plugin for GitLab there. And I wanted to ask it about the files that I needed. I wanted to ask it the content of the files. And I wanted to ask it about basically how to run it. Okay? So you're going to see a bunch of questions first. So here I'm asking it, I want you to create a hello world application, simple application for Quarkus that I can natively compile. So then it returns to me lots of information. At this point, all I cared was about the actual hello world program, which is at the top. We'll check it in a minute. I'm making the window here bigger. Now I'm asking it to provide to me the Dockerfile native file for this sample application. And then it returns to me the content of that file. Now the next thing I'm going to ask it is, I want the pom.xml, which is it's needed for building the application, for this application. So it gives me the pom file contents right there. So I'm going through a series of questions so I can get all the stuff that I need so I can start creating the project. Then I ask it, I want you to give me the content of the tests that I can use to test this application. Okay, it gives me all that. All right, then I asked it, so it gave me all this stuff, right? And I need to know where to place that. So I asked it, give me the directory structure of where I should put all these files. So it gives me a whole directory structure there where every file should live and an explanation of what each of them does. So here, I'm going to make this window on the right bigger because I'm going to be now copying and pasting all these files into my project. So there is the directory structure. There is a source, and there is a test subdirectory. There's also a target subdirectory. So I'm going to start creating the files now. First is the hello resource file. So I go to the chat, and I'm going to scroll up all the way until I see the content of that file. So I'm going to do a copy and paste. So here I'm pasting the content of that hello world Java class. Then, so that's one file I'm creating in the project. Then I'm going to go and create the second file. Now the second file is an application properties. I noticed there was an application properties file in what it gave me, and in the directory structure, it just happened to be empty. I wasn't sure whether I needed it or not for the whole thing to compile, so I created it anyway, and I left it. It's going to be empty. The next thing I'm copying is the actual test, the test file for this application. And I just created the file in the project, hello resource test. Now I'm going to copy and paste what chat gave me all from the chat window to the project itself. So the next file is going to be okay, so when you compile Java in Quarkus, for the test, you also need an extra file called hello resource IT, okay? So I copied and pasted that file content also. It's supposed to be empty because it inherits from the other file, and then it's going to use this, like, think of it as a wrapper to compile that to native, to machine language. So the next file is the POM XML. Again, it's the same exercise. I go to the chat. I'm going to copy the content of the POM XML, and then I'm going to copy it over to the project. And while I was at this file, I want to update the name of the artifact here from Hello World Quarkus to Quarkus Native. And then I'm also going to update the version of Java from 11 to 17, because I know that as of today, Quarkus supports 17 and higher, not 11. Very good. Now the next file is the dockerfile.native, which is in Quarkus you have to have a .native Docker file. So I'm going to again copy from the chat to the project. Excellent. Okay, so I save all the files, and then I'm gonna move forward to later in the recording here. And at this point, I have all the files that I need. I'm gonna build and run this locally. Now I run the Maven command to compile this, and I get an error, okay? Now I look up and I notice that there's an error there that I don't have GraalVM installed on my machine. So GraalVM is an open source project that is the component that compiles the Java code to a native image, or to the executable code, machine code. So I'm asking now chat, listen, I tried to compile this and I got this error. What should I do? So it's telling me, hey, you need to install GraalVM on your laptop, and you need to run this command brew install. So I just copy and paste that, and I installed that GraalVM on my Mac. All right, I just make sure that the installation completed there. I look at the contents, and I notice that it's Java 17-22.3.1. I make a note of that number. Okay, and then I'm going to go ahead and include those the location of this directory into my path, into a variable called Java home. I just fixed the version of GraalVM there. Then I'm going to define an environment variable for GraalVM home. I hope you can see that. That's not too small, is it? So? Okay. And let's see, what am I doing here? So I'm updating my path variable so that all the commands are picked. Now I run xattr, which is necessary on the Mac platform to get that program that I downloaded out of quarantine. So I will be able to run GraalVM locally. I double check the Java version, and then I rerun the Maven clean package -p native command on my local laptop. And this time it should work. Yeah, it's getting further. Now it's generating the executable right here. This is it's basically compiling Java into machine code. There. Done. So just make sure it places everything into the target directory. So I'm going to go into target, and I see, look, that file that says -runner at the end is very large. Right there, that's the executable. Okay? So I should be able to run that locally. So I run that locally. I'm running the executable here locally, and then I go to a browser window, and I'm going to open the application. I point to localhost 8080. All it does is just returns hello world, so it's running on my machine, and it's good. So So now that I got everything working locally, now the next step is going to be, I need to do this now on the cloud. So I'm going to need a CI/CD pipeline to do this. So let's, but before we do that, let's just commit everything and push everything to the main branch. I'm not working on another branch here. I'm just committing to main. All right, good. So now let's move on now. Okay, so now I'm going to pause this for a second here. Okay. So your prompts can be short or can be long. Okay, usually when the more specific you get in your prompt, the more specific the answer will be from the AI, the LLM basically. So here I'm asking Duo Chat to generate a pipeline for me. And I'm telling it I want 3 stages: build, containerize, and deploy. And I'm describing what I want in each stage. Okay? And I'm telling it I want to use a Mandrill is the, so the reason that I used GraalVM before is because GraalVM has a Mac executable basically. You can install it on Mac. So Mandrill is a downstream of GraalVM that is optimized for Quarkus. Okay, and it runs on Linux. It doesn't run on Macs, on Mac machines. So now I'm telling it I want to use Mandrill. I don't want to use GraalVM anymore. Okay, and I'm telling the prompt that. And then I'm at the end I'm saying I want also at the end I want the deployment to deploy to the production environment, and I want you to use these environment variables also. So now it generates a pipeline file, a .gitlab CI YAML file. And then what I'm going to do is I'm going to copy and paste, just like before. I'm going to create a file called .gitlab CI YAML in my project. And then I'm going to paste the generated information for the pipeline from the chat window to this file. Now I look at it and I notice that it's generated. The content specifies that this pipeline should only run on the main branch. I don't want that. I want to keep it simple. So I'm erasing that rule from all of the 3 stages or jobs. And then I also noticed that dockerfile.native had a -micro at the end, so I'm deleting that because I know that my Docker file is called dockerfile.native. Okay, so one thing this didn't have was the production deployment at the end. So now I'm asking chat, hey, what is the syntax to specify an environment with its URL in a pipeline? So it gives me the syntax. So I'm going to copy that over to my pipeline. And I'm going to place it at the end of the pipeline. Now I have the syntax, but those are dummy variables, so I'm going to update that. I want the name of the environment to be production, and then I'm going to update the URL to be the URL that I'm going to use, which uses an environment variable. Then I notice there is a script here, mvnw, that I don't know where that came from. So I ask chat about it, and look at what chat says. It says, unfortunately, I could not find any documentation about it, okay? So again, in this case, you have to be more specific. So I re-asked it, and I said, how can I get the mvnw script for Quarkus? Because I know that I need this to be able to run Maven with Quarkus. So there, it gives me instructions on how to do that. So I just use the most simple instruction, which is to run a Maven command called Maven wrapper:\wrapper, and that actually generates and creates this mvnw command that I check right there. I do an ls and it's right there, and it's executable. So I should be okay now to run the pipeline. I think I clear all the potential errors. So let's go ahead and commit this to the main branch. And when you commit this to the main branch, what it's going to do is it's going to launch a pipeline automatically. And sorry, I was a slow typer there. Okay, good. So now that we push this into the main branch, it's going to launch a pipeline, which we're going to go see next. Now, the pipeline has 3 stages and 3 jobs with the same names: build, containerize, and deploy. Notice that build failed. Okay, so let's go into build, and let's see what's going on. And look, there's a troubleshoot at the end of the job log. So let's click on that, and it's going to give me an explanation on the right side about the cause of the failure, examples on how to fix it. Okay. So I noticed that the error has to do with an option that is being passed to that image. So I'm suspecting here that is the entry point, that the image, which is not mine, is the manual image, has an entry point that has an option -C, because I'm not passing that to it. So I'm going to go back and I'm going to modify the entry point for that image. But I don't quite remember what the syntax is. So again, I asked Chad, hey, what is the syntax to override the entry point of an image using GitLab keywords? So this is going to tell me the syntax, and I'm going to remember, okay, so this is the syntax. So I'm going to copy and paste this into line 21 of my pipeline. And I'm going to adjust that image, and I'm going to use the name keyword there, and then I'm going to add an entry point at the second line, and I'm going to pass it a null string. And that will take care of that -C option that is being passed to it. Notice that if I had not been using AI here, it would have taken me longer to figure things out. I would have had to go into the documentation, maybe do a Google search, Stack Overflow, and do some reading to figure out what the problem was. Okay, so now we commit, and then this will launch another pipeline. Build passes. Okay, so let's go check build. So build is successful. At the end, it looks good, although there's a warning message there that catches my eye. It says something about the location of dockerfile.native. Okay, it's expecting it to be in source main Docker. And then I go into containerize, and I notice that the Docker build failed. And it's using the same location for that dockerfile.native, but the dockerfile.native is in the root directory of the project. So that's my mistake, right? So I click on troubleshoot anyway, and that's what troubleshoot is going to confirm my suspicion. That, listen, look at the directory structure. I think the file is in the wrong place. So I go back to the project, I fix my pipeline so that I fix the path of the dockerfile.native file, which I think happens in the build job and in the containerized job. So I just erase the prefix of that path and just leave the file alone there, because I know that it's in the root directory of the project. So I fix those two, and I'm going to go ahead and commit and push that to the main branch, which again, it will launch another pipeline. And hopefully this time it should work. At least containerize should pass. And we already know that build is working. All right, cool. So let's go back to the pipeline. Okay, so build should pass, containerize hopefully should pass, and deploy also passed. So the deploy should have deployed the application to a Kubernetes cluster that I already had connected to this project. I checked the output of the job, and it looks good. Deploys looks good, and remember, deploy gave me the link of the URL of the application. So when I click on that, it should open a web window here, web browser window. I pass the warning of the HTTPS because I have no certificate, and hello world is returned. Now I'm clicking this in the log file, but remember, we also had an environment section in there, so we should also have an environment called production, which is right there, and that button right there, open, that's a URL that we specified in the pipeline. When I click on that, you also see the hello world. So it's working from those two different locations. So now, hopefully, you got an idea of how to leverage AI through the entire, development life cycle that, and the workflow that we covered before. Okay? I'm out of time. I'm so sorry. Thank you so much. So if you have any questions, please just come to the front and we can chat here. Okay? Thank you.